done it at home.
Let's do it.
Oh, we'll do it here.
Do it? Okay. Temperature and pressure constant. Particles increase. Then the volume must also increase. Then the volume must also increase. So we're doing S4, temperature and pressure constant. Temperature's constant, so what else is constant?
Speed and kinetic energy.
Speed, kinetic energy, and
Oomph.
oomph.
These are constants.
Number of particles increases. What else increases? Mass.
Put a bunch of kids in a room.
It says the volume must increase.
If this goes up.
What's the tricky one in this one? Collisions per second per area.
Yeah, because if they're both connected.
This is the one where you're adding as you blow up the balloon, you're blowing more particles in, right?
It's also
But the balloon's expanding at the same time. So if you looked in the ultrascope, remember, is just a little dot in that whole big thing. If you looked at the ultrascope, you'd still see the same number of particles in that little section, even though in the whole balloon, there's more particles, right?
I don't know if this is right, but I kind of think of it as the number of chances. The chance that they're going to run into each other.
The chance that
So
they're
if
going to
there's
run
more
into each other.
room, the chances that they're going to run into each other
Okay, that makes
would
sense.
would not increase. You know what I mean?
Yeah.
If there's more room for the more particles,
Yeah.
if they're expanding as
So it
they're
doesn't-
going. Yep. They kind of stay in proportion. So what is this one? Temp is
Constant.
constant, mass,
increase.
volume,
Increase.
kinetic energy,
Constant.
speed,
Constant.
particles,
Increase.
collisions,
Constant.
oomph,
Constant.
pressure.
Constant.
Do those last three make sense?
Yes.
Yes. Now, let's pretend you had to do the narrative for this one. You do have to do a couple of narratives. The key to the narratives, see how in the question it kind of tells you some stuff? The key to the narrative. The first sentence is the question and the answer. That's what they tell you. If the temperature and pressure remain constant, if the total number of particles increases, the volume must increase. That's your first sentence. The first sentence is the question with the answer. That is the question with the answer. Then you just simply have to make sure you mention each thing. If you want to say, because temperature went up, then we know kinetic energy, speed, and oomph go along with that. And because there's more particles, we know there's more mass. If you want to relate them, that's fine. As long as you mention every single thing, okay? And then your last sentence must be something to the effect, doesn't have to be this exact wording, but according to the SPT mechanism, pressure is related to, just remember this, you're going to have this chart right in front of you. Just remember these last three are related. Pressure is related to these two. That's your last sentence. Since pressure is related to this, and since this went down and this went up, then pressure has to be constant. Or since this went down and this went down, then pressure has to go down. Or since this went up and pressure went up, this has to, okay? So your last sentence has to be that.
So the first sentence is pretty much describing the
It's
table.
the question.
Okay.
With the answer, because the answer is given in the question.
Okay.
Okay? So the last sentence, according to the SPT mechanism, since pressure is related to collisions per second per area times oomph per collision, and since, if you were doing this one, since CSA goes down and oomph goes up, then the pressure must be constant. Okay? Or if you're doing this one, since CSA goes up and oomph goes up, the pressure must increase. The narratives are so easy in this book. They're so easy. Say the question, go through each thing in the chart. I don't care if you just go through each one individually. You don't have to relate it. Make sure you do them all. Say temperature, the mass. Make a tiny little 3-word statement about each thing. and then ended with that
Right.
sentence.
So we
Okay?
just write the exact same thing.
Since pressure
So we
is
don't- so
related
we just
to,
write the
and you've
sentence.
got that right in front of you. Remember, if you get confused on the test about something, look at the other parts of the test to see if that something is there. Okay? All right, now, on the exam, there are two things that I used to not show the students these before the exam, but then I realized that was making them nervous about something they shouldn't be nervous about. I think that I have enough for everybody. Let me just make sure. Yes. Almost. You still have some? No. No? Okay. All right, you guys share and you can share over here. Lonnie and Kelly can share. Oh, you're okay? Okay. All right, you got, everyone's okay? All right, now there's two questions like this on the exam. All right, so what you have is 3 ultrascope pictures, right? Can you see the 3 ultrascope pictures? And Chelsea, maybe you'll show, maybe you'll take the camera and show them the 3 ultrascope pictures. So, and I put this in modules under study guide. I put this, I took a picture of it this morning when I did the other study session, and put it up on Canvas, so you have this on Canvas.
Focus.
Okay? All right, you've got the data. Let's look at the data. What is happening to the number of particles? You've got 0 seconds, 30 seconds, 60 seconds. You start with 60 particles. At 30 seconds, in the ultrascope, you have how many particles?
42.
And at 60 seconds in the ultrascope, you have 30. The number of particles is definitely changing. Now, look at the speed. At 0, it's 466.3. At 30, it's 466.2. At 60, it's 475.9. That is negligible. It might as well be 466.4, okay? Okay. If the speed is changing, it's going to be like 650. Look at your ultrascope data, okay? For when you're heating, look at the data. It changes drastically, all right? This speed is basically constant, okay? After 30 seconds, it's exactly the same. It just, that snapshot in time, it happened to be up a tiny bit. Now, there's going to be 12 possibilities. You have to determine which experiments could yield the pictures at the right. You go through all 12. Look at the first 4. The first 4 have to do with what? Heating and cooling. If there's heating or cooling going on, what is going to happen to the speed? The speed is going to change a lot, right? So what do you do with the first 4? Not possible. Now these ones, one of them has like 5 answers. One of them has like 2 answers. I don't remember the exact number, but sometimes you can circle like 5 of these. Sometimes you can circle 1 or 2. Don't think there's a certain number you have to circle each time. Yes?
Are you saying that none of the first 4 are right?
Correct.
None of the first 4 could apply to this data
Because the speed is constant, so the temperature is not changing.
because the speed, if
So we're
the
not-
speed
we're not
was
heating or cooling. We're
not heating
466,
or cooling.
666, and 966,
There's not a
then
significant
you
change
could
in
say
speed.
heating was going
So
on.
it's going to be a huge increase.
If the speed was 466, 266, and 66, then you would know cooling's going on.
So it has to be a drastic interval change.
Yes.
Okay.
So we know it's not 1 through 4. Now, gas was added to a fixed wall cylinder. If you are adding more gas to a scuba tank or a solid container, what is going to happen to the number of particles in the ultrascope? It's going to increase. What's going to happen to the number of particles in the whole container? It's going to increase also. So remember, you've got to pay attention to the details. Are they talking about the container? Are they talking about the ultrascope? Sometimes they'll be the same, sometimes they'll be different. You got to be thinking about that. 6, gas was added to a movable wall cylinder. If you're adding gas to a movable wall cylinder, what's going to happen to the number of particles in the ultrascope?
They're the same.
If you're adding it to a movable wall, the total number of particles in the container will increase, but how about in the ultrascope? Remember, the ultrascope is just a tiny little peak into that big container. That's what the ultrascope is representing. Okay, so could number 6 apply to a movable wall cylinder?
No.
No. If the numbers were 60, 60, and 60, how about number 7? Gas was removed from a fixed wall cylinder. Gas was removed from a fixed wall cylinder. The particles decreased. Would that fit with gas being removed from a fixed wall? Mhm. You would circle 7. 8. Gas was removed from a movable wall cylinder. If gas was being removed from a movable wall cylinder, now the cylinder's going down, what is going to be true about the number of particles in the whole container? The whole container is decreasing. How about in the ultrascope? In that tiny little picture, it's the same because the gas is being sucked out and it's going down at the same, they're related. Okay? So that one would not work. The movable wall of the cylinder was pushed down.
No.
Pushing down the movable wall. No. The movable wall of the cylinder was pulled up.
Yes.
You haven't added any more particles, but you're making the cylinder bigger.
Yes.
So 10 you would circle. 11, nothing was done to a fixed wall cylinder. Nothing was done, what would happen with all the numbers?
Same.
All be the same. Nothing was done to a movable wall cylinder. Nothing done.
I'm so confused with, the movable wall cylinder was pushed down, and then the other one, what is that?
9 and 10?
Yeah.
Okay, so you're not putting or taking away gas. You're just taking the balloon and you're making it smaller. You're squishing it down. A balloon's not a good example because it makes you tired. One of those syringes. Okay, so you're opening the syringe up. You have the same number of particles in a bigger space, or you're closing the syringe. You're pushing the syringe in. Now you have the same number of particles in a smaller space. Okay? All right, so how many of these are on the exam? 2. Okay? 2 of these. And you need to, again, if it's heating or cooling, you're going to see changes in the speed. If it's movable, you just got to look at the data first. Pay attention to the data first. And again, the changes will be not like 466 to 475. That one doesn't make sense because if it was being heated at 30 seconds, there would have been a change too, right? Okay, question. So 7 and 10 only. 7 and 10 on that one.
With the movable wall of the cylinder is pushed down, could you give us an example of like what an ultrascope would show for that if that was on the test differently?
So number 9, the movable wall of the cylinder was pushed down. So you have the same particles, now they're in a tiny space. So let's say this ultrascope says 100, and after 30 seconds,
Be 120,
be what?
it'd be more, because they have
120 or
150,
140, or let's say 150,
150, and
And
then if
after
you do it more, it'd be 200,
200.
because you have less space for the particles to move
Now
around,
they're
so
all
more
packed
would be
in.
in the scope.
Remember, you're just taking a little snapshot of that space. There's going to be more particles because now you're putting them into.
So it would work in this way.
Yeah, I feel like I'm just overthinking
Like how
it.
this goes
Yes.
The
from.
data was
do that.
reversed, yeah.
Yeah, okay.
Yeah.
Okay, thank you.
So, like I said, this is on Canvas. Okay? All right. Now I want to know if you have any questions.